All right. Hi, everybody. So, subject was announced. I'm Gérard, CTO of Logion, and let's go. So first, what is Logion? Well, actually, Logion is the legal tech for tokenized economy. So what we do is enable the creation of legally binding tokens. And we do so by providing a framework for compliant tokenization. And this allows us basically to create a trust-minimized market for real-world assets. And we also offer a tool set for secure digital ownership. Our vision is to enable people to protect their rights and the value they create in exchange on the Web3. So, why did we create Logion? Basically, I don't know if you know, but the world is about to get tokenized. And so we believe that we must bind digital assets to people, companies, rights, laws, and obligations. Otherwise, no mass adoption because no rights and no regulatory approval. So there are three key features that we have at Logion. The first is the proof of law, which is basically the fact of binding the obligations, rights, and benefits to a token. The restricted delivery, so basically the possibility to give access to files only to the token owners. And finally, what we call Logion certificate, which is a confidentiality and privacy-preserving way to actually verify data, documents, and so on. So the foundations of our proof of law is first a blockchain operated by judicial officers. Second, a network of verified issuers, so those are people whose identity is known and we can trust them. And we have two other foundations which are more technical, I would say. First is a private and encrypted distributed storage. And finally, a zero-knowledge proof system of evidence records. How do we actually work? Well, quite easy, actually. Minters and verified issuers come and record data on our platform. Our judicial officers create certificates. Then tokens are minted and linked to the certificate. And finally, if it applies and the asset's life cycle and the asset actually has a life cycle, well, the certificate may evolve to actually reflect that. So I will now dive a little bit deeper into our system. So I will first present our data model, our processes, our architecture, and then show you a quick example of how it applies. Let's go. At the heart of our system, there is the legal officer case. We call it a lock, which is basically a data structure which is combining on-chain and off-chain data. So on-chain data are all public, of course. And off-chain data, they are mostly private. And behind each Logion certificate, there is one lock. A data model of a legal officer case. A legal officer case has an owner, which is one of the judicial officers, which is in charge of it. There is a requester, so basically a Polkadot address. There is a type. Today, I will focus on the identity and collection locks. I will explain later. And in each lock, you will have a collection of files, public data, and links, potentially links to other locks. So the life cycle of a lock is as follows. First, you have a requester, which actually creates a draft and submits it to the owner, potentially after already enriching it with data and files. So if the lock is accepted by the owner, the requester is able to publish it on chain, and after that, the owner is actually able to acknowledge that publication. And once everything is fine, so all the data, all the files, all the links are there, and everything is fine, we are able to close the lock. And that's the moment where the certificates can be considered as fully applicable and done. In terms of identities, because that's a little bit at the heart of what I'm presenting here. So the judicial officer's identity is known, it's public, something that's known by everybody. However, the requester's identity is something that's, well, kept confidential, all right? So how do we do that? Basically, we create identity locks. So identity locks are there as kind of containers for all the data required to actually identify someone. And, well, those data remain fully private, of course. And the thing is that once an ID lock is closed, you can consider the ID lock certificate as a zero knowledge proof of the fact that the identity of someone which is behind an address is known and has been verified. And that's really important because it's only on that condition that actually a requester is able to create what we call a collection lock. What is a collection lock? A collection lock is a special kind of lock which is there to actually contain all the data which are required to describe a set of, I would say, safe tokens, so legally binding tokens, right? So as I mentioned, requester must be linked to the owner of the collection lock by an ID lock. And once the collection lock is closed, what we can do is start to associate items and records to it. So a collection item is actually an object which is linking an NFT or a set of fungible tokens or a set of semi-fungible tokens. It depends on the blockchain you are working in. But it's linking those tokens to the collection lock, all right? It may have some files attached to it. So for instance, you want to associate the digital asset which is linked to one of your NFT, well, you will attach it to the item. That's where it goes. You may also attach terms and conditions about the usage that actually applies to the digital asset which is linked to the item. And finally, yeah, all the data which are linked to the item are public, except for the file's content, of course. Tokens records, well, they are more or less the same. They can also be published later and attached to a collection lock, but they are not linking anything. They're just there to publish some additional documentation which must be contributed after the collection lock was closed. So for instance, let's say you are in a case of real estate tokenization, all right? You may have to publish every year a proof that, first, your building still exists, and second, that the loans are being paid properly, and etc. One very important building block of our platform is what we call the ownership check. So we have to be able to check if you are actually the owner of some token. How do we do that? So first, you as a user are identified by a public key, by your address, actually. So we have to first verify that you are actually the owner of the private key that's behind it, all right? So how do we do that? Well, basically, you request a challenge from our platform, sign it, send the signature back. We verify that the signature is valid. And if it is, we send you back an authentication proof. That authentication proof is simply a JSON Web Token that you will be afterwards reuse to actually interact with our API, all right? And basically, once you interact with our API through an authenticated call, we are actually able to verify if indeed you are owning that token by interrogating some kind of external service. So the restricted delivery is that feature. Once we actually verify that you are indeed the owner of a given token, it's the fact that we are opening you the access to some files contents, all right? So there are several levels for that. First level, so as I mentioned, you can attach files to the collection item. If you are the owner of the token of the item, well, you have access to the files of it. Another special case, we can also open access to files which are attached to the lock itself. There, the rule is a little bit different. We just verify that you are one of the owner of tokens attached to the whole collection, all right? Same goes for the tokens record files. So I was talking about the Logion certificate at the beginning of this presentation. Here, this is what it looks like. It's simply a web page, actually. And you can see it as a kind of viewer of all the public data that are available on-chain. And it's a little bit more than that if you are targeting one specific item, because at that point, it also opens access to the restricted delivery feature, where basically you are able to authenticate. And if you are authenticated and we are able to verify that you are indeed owning the token, then basically you have a couple of buttons appearing and giving you the possibility to download the files and list the tokens records which are associated with the collection lock. So that was about the data model and the processes. So let's now talk a little bit about the architecture of our platform. So that's more or less the kind of stuff you see all the time. We have nodes, we have edge nodes to access the content of the blockchain. The specific part we have is that our nodes, there is, in addition to the substrate service, also a Postgres database which is running, which is used to actually store private data. We have also the services which are linked to our private IPFS network, all right? Because we are not using the public IPFS. We are only using the IPFS we're running on our own nodes. We have, of course, the Logion off-chain service, which is running. And then, as a client, we have a web application, which is basically, interacting with your MetaMask or your Polkadot extension to have access to your keypairs. Not directly access your keypairs, but being able to use them to actually sign some stuff, etc. And we have also a directory, which is basically there only to expose the public data which are identifying the legal officers. So the link between a legal officer and his node is something that's stored on chain, but we also need some additional information like the address, the phone number, the mail address, and stuff like that. So how do we achieve data privacy in that kind of architecture? Basically by carefully choosing where we put our data. So on-chain substrate storage, that's for public information only. And all the private data are going either in the IPFS network, so that's essentially for the files, and in the private databases, that's for all the rest, I would say. So IPFS and databases are, of course, not accessible directly from the user perspective, I would say. You have to pass through our off-chain service, which is implementing the authentication that I was describing previously. And another important stuff is the fact that nodes are not sharing data, right? So someone which is looking at the data on one node does not have access to the data of another node, even if he's actually participating in the same IPFS network. Why? Because we are actually encrypting all the information we are storing in the IPFS, and each node has its own encryption key, right? That's very important. And regarding the databases, I will not dive into that, but we actually implemented a mechanism which is able to produce almost real-time backups of the database and inject them in the IPFS network. Again, always in a way that actually we are encrypting everything. So, quickly, a little example. How does that work? First, here you have the screen of what requester would see. So the requester, who's that? Basically, you are a tokenizer. Okay, you are about to create your items, first stuff. Well, after identifying yourself, you are creating your collection lock. You are providing a bunch of data which are actually required to make sure that indeed you are the owner of the building. You have all the rights to actually sell part of it in the form of tokens. And we verify who you are, and et cetera, et cetera. Okay? This lock here, we see that all the information have been recorded and acknowledged. It's closed, so we are actually able to publish items if we want. Second, let's say that you are actually publishing your items in the forms of an ERC, 11455. All right? Well, that's a very, very simple form. Of course, you will not use that kind of stuff. But the interesting part here is the fact that we are providing a little Logion smart contract, which is actually there to help you. It implements those three functions, read functions, which are actually there to show that indeed your contract is linked, and the items, the tokens, sorry, it will actually mint. It shows that everything is linked to one given lock and its items. All right, so we have a kind of backlink from the contract to your certificate. Also, if you are using ERC 1155 tokens, you will more than probably have metadata. So those metadata, you should also put all the information in there. So this is you have the collection ID, so that's the ID of the lock. item ID, that's the ID of one single item which is actually linked to your NFT. And finally, you have the address of the certificate, all right? And the advantage of putting that in your metadata is that basically more than probably a platform that's actually displaying your NFT will use those metadata to actually display some stuff, in particular the certificate, right? So this is actually the item you will create in addition to the lock, the contract, and the token that you minted. So here well, maybe don't see it, it's a little bit small, but here it's an ERC 1155 girly token. We have the identifier here, which is a composition of the address of the contract and the token ID, all right? And after that, you have the certificate. It looks a little bit like the certificates you've seen before. The only difference is that here, I did not yet authenticate, so there is still that button, which enables me to actually choose, well, the extension I want to use to actually authenticate and check the ownership of the token. So, as a conclusion, we covered Logion's data model and processes, at least a part of them, the most important part. We discussed a little bit about how we are actually protecting privacy and confidentiality in our platform. And we covered quickly a simple example of real estate tokenization with a really simple contract that you should not use in production. Thank you. And if you want to dig a little bit deeper, well, feel free. We are not hiding anything. Everything is open source and published and available. And that's it.
Thank you, Gérard. And now we have some minutes. If somebody has any question, please raise your hand. And no questions? OK, there's one question there. You have the microphone over there.
All right. Thank you very much. Can you talk a little bit about actual references? Is it already live somewhere? Has some reputable company already done anything with it or anything like that?
So, yeah, so the system is production ready. It's already running. We have several, well, test environments, but those are not test nets in the in the way we are generally seeing them. But we have a production environment. We have some use cases, which are we have a project with I don't know, can I say it? Well, we have a project with block.imo. I don't know if you know them. There will be a real tokenization happening here beginning of July. And yeah, we'll probably hear of it if you follow our Twitter and our LinkedIn and stuff. There will be some announcements soon.
There's another question over there.
Can you tell us a bit about how you manage the certificates? So that's chronically difficult, yeah, especially at scale. You know, the inscription certificates. So what's your approach here? How to scale?
How to scale?
Yeah, regarding the encryption certificates.
The encryption?
Yeah, data encryption certificates.
Well, we did not yet face scalability issues linked to encryption. But basically, the thing is that as we have several nodes, well, each node is responsible for one certificate. So unless you are actually, well, grouping all your certificates on one single node, well, you are able to actually, well, spread the load. I mean, so that's basically the way we will be doing it. I don't know if that answers your question, actually. No. So I did not understand your question, I think. Can you maybe repeat? Can you rephrase your question? I did not understand that.
I'll try. So essentially, you have this network of nodes, yeah, who transact. So you have two nodes. If I understood you correctly, maybe I didn't, yeah? So you have this network of nodes. They share encrypted information through transactions, correct?
Yeah, but so each node is responsible for encrypting its own data, okay, once. And after that, the data are more or less spreading across the network using IPFS.
And who guarantees the authenticity of this network or this node certificate? Do you have an instance? Who is the final authority to judge?
Sorry, I really don't understand you.
Yeah, I know.
Maybe
I can claim something about myself, yeah? Who is going to attest that what I'm claiming about myself, that I'm the authority here, is really true?
sorry, there is too much noise. I really don't. But you know what? I will come to you later, and I will.
Offline.
Because sorry, I'm really sorry. I don't hear you.
Okay. Well, maybe you can ask him now under the stage. So thank you so much, Gérard, for your
Welcome.
talk. Thank
Sorry.
you.